Our next lesson is on independent and dependent events. Events are independent if the outcome of the first event has no effect on the outcome of the second. For example, if you flip a coin and then roll a die, those are independent. How the coin lands has no effect on how the die will land. Events are dependent when the outcome of the first does have an effect on the outcome of the second. Imagine you have a deck of cards. If you draw the ace of spades, and then you draw another card, you cannot draw the ace of spades again. It's already out of the deck. Those are dependent events. So if A and B are independent, then the probability of A then B happening is just the probability of A times the probability of B. However, if they're dependent, then the probability of A then B happening is the probability of event A happening times the recalculated probability of B happening after A. And what I mean by that is the probability of drawing the ace of spades from a deck of cards is 1 out of 52, because there's one ace of spades and there's 52 cards. If you draw that out now, and say the second event is drawing the 2 of spades, you now have a 1 in 51 chance of drawing the 2 of spades, not 1 in 52, because there would only be 51 cards left. That's recalculating. So, some examples. Bev spins 2 spinners. The first has 5 sections. 2 are blue, 2 are yellow, and 1 is orange. The second has 4 sections. 2 are red and 2 are green. Are spinning these spinners dependent or independent events? So you spin the first spinner, and then you spin the second spinner. Does what the first spinner land on have any effect on the second spinner? The answer is no. If there's no effect, then they are independent. Independent. So now we're asked to find the probability of yellow-green. That means the probability of spinning yellow on the first spinner, then green on the second. Because these are independent, that's P yellow times P green. Well, yellow, there are 2 yellow sections out of 5 total, so P yellow is 2/5. And P green, green has 2, and there are 4 total sections on its spinner. So P green is 2/4. We're just multiplying fractions. Let's see, the 2 and the 4 can cancel to become 1 and 2. The 2 and the 2 on top of each other can cancel and both become 1s. In the numerator, 1 times 1 is 1. In the denominator, 5 times 1 is 5. So we have a 1/5 probability of yellow-green happening. If you forget to simplify your multiplication ahead of time and you multiplied this through, you would have 4 over 20, which you would still simplify to 1/5. Two sets of index cards are numbered 1 through 5 and placed in a bag. It means there's 2 1s, 2 2s, 2 3s, 2 4s, and 2 5s. Liza draws a card and does not replace it. This is your first event. Then Ben draws a card. This is your second event. Are these dependent or independent? Well, there's 10 cards in the bag when Liza draws, and she picks one out and doesn't put it back, which means there's only 9 cards in the bag when Ben draws. So have we affected the probabilities? Yes. The first event has 10 possible outcomes, the second only has 9 because of the first. The first event definitely has an effect. We're then asked to calculate the probability of drawing a 4 and then the other 4. So remember, this is now the probability of drawing 4 times the probability of 4 after drawing the first 4. So when Liza goes to draw her first card, there are 2 4s in the bag. Remember, there's 2 of each number to start with. So there's 2 4s in the bag, and there are 10 total cards. She's drawn a 4 out. It's out of the bag. So now there is 1 4 left in the bag and 9 total cards. So the probability of drawing the second 4 is 1 because there's 1 4 left over 9 because there are 9 cards left. This multiplication we can simplify 2/10 to 1/5. 1 times 1 is 1. 5 times 9 is 45. There is a 1/45th chance of drawing 4 and then drawing the other 4.